All right, today we are simplifying algebraic expressions. And in that process, we will be combining like terms. Our learning objectives: by the end of class, you should be able to say, I can simplify algebraic expressions by combining like terms. You should learn about today the different parts of the algebraic expression and what like terms really are. Okay, an algebraic expression is a mathematical phrase that uses numbers, variables, and operation symbols. 2x plus 7 is an example of an algebraic expression. A variable is a symbol that stands for one or more numbers. X, y, and n are examples of variables. Can you write an example of an algebraic expression? Let's see if we can give this a try. And so let's give an example. Let's go back. I don't know how to go back. Go back. There we go. Examples of variable expressions. You might have 2x plus 7. We might have -5 minus 2a. Another one might be, oh gosh, let's get really crazy and say x squared plus x. Those are all examples of variable expressions. Algebraic expressions can be broken into different parts that we call terms, variables, coefficients, and constants. We often forget about those, so we have to be careful. We're going to dissect this one. 5x plus 3y minus 8. These each are terms. The terms are separated by the pluses and the minuses. How many terms do you see here? Well, let's see. Let's look for the plus and minuses. There's one, there's one, there's one. So we've got this one, and this one, and this one. And here you'll see it's very important that I'm including the sign with the term. So those are our terms: 6x squared, 4y, -6, 7x, and 9. This algebraic expression has 3 terms. Is that true? Well, let's check it out. We've got a plus, a minus, and a plus. Well, there's 3 of those. Let's see. So I've got 7b, positive a, negative b. Oh, but wait a minute. Now I've got this. It appears to be 4 terms. So this is false. All right. Let's look at the coefficients. The coefficients are factors associated with the variables. Now, a factor is a number that you use when you multiply. Notice we are multiplying 5 times x and 3 times y. We do not call -8 a coefficient because it does not have a variable. Those are our variables, x and y. And finally, -8. Notice the number in front of the 8. That's a negative, so we include it with the 8. The -8 is the constant. It's just a number, and it can stand alone. We want to circle the coefficients in red, the variables in yellow, and the constants in blue. So let's go red for the coefficients. I've got -3. I've got 5. It's a positive. I've got 7. And then, believe it or not, there is a coefficient here in front of the n. We don't write it because it's a 1. We need to understand that if there is no coefficient, we understand that coefficient to be 1. Now let's go with blue. So blue are the yellow are the variables. We've got n and s and n and s. And finally, let's look at the constants. I've got a negative 12 and a positive 6. That's how that looks. We want to place a red dot above the coefficients and a blue dot above the constants. See if you can name the coefficients. And now, see if you can name the constants. So let's get our dots. Let's see, red dots are for coefficients. 10 is a coefficient, as is 5. 3 is not a coefficient. There is no variable there. Coefficient, coefficient. Blue for constants. Okay. Oh, negative 3 does not have a variable. And 15 does not have a variable. So can you tell the difference between a constant and a coefficient? What do you think? Well, if you think that constants are standalone and coefficients are always attached with a variable, then you're right. Now, we'll get these long algebraic expressions, and it's always in our best interest to simplify them, make them more simple. And we do that by combining like terms. It doesn't change the value in any way. That is the value of the expression in any way. So, like terms have exactly the same variable. That is to say, if constants have no variable at all, well, that's the same variable. Consider the following expression here. 3a is like negative 6a. 5b is like negative 2b, not because of their coefficients, but rather because of their variables, a and b and b. And these two are constants and they have no variable at all. If we were to combine 3a with negative 6a, that is add them, we would end up with negative 3a. Combining 5b and negative 2b gives us positive 3b. And finally, we can combine our constants, negative 7 and 10, to get a positive 3. So in other words, all of this can be simplified to negative 3a plus 3b plus 3. Algebraic protocol has us putting our variable terms in alphabetical order. So it is most correct to have the negative 3a appearing in our expression before 3b, because a is before b in the alphabet. So here, let's do an example. We are going to simplify the following expression by combining the like terms. Let's look at this. 4a is not like 7, but it is like 2a. If I combine these, I get 7a, and then I bring this in, and 7. I may not combine these two because they are not alike. So we would not write our answer as 13a. No. We stop here. We are done simplifying. How about this one? Let's look at the like terms. I've got a negative 4x, a negative 3x, no more variable terms. These are constants, and they are alike. They happen to all be positive. So now let's combine them. These, whoops, that should be blue. Negative 4x and negative 3x give us a negative 7x. Then 3 and 8 and 2 gives us 13, positive 13. So our final answer is negative 7x plus 13. And we stop there because negative 7x is not like 13. We may not add them. One more. Let's circle our like terms. So I have 12h. I've got negative h. Remember, that's a negative 1h. And then I have a negative 2h. Well, let's combine them. 12h, negative 1h, that's 11h. Minus 2 gives us 9h. I'm going to double check my math here. Yes, that's 9h. And negative 17 and positive 16 gives us negative 1. I'm done. I may not combine these. They are not like terms. So how did you do today? I hope this is helpful as you go through your practice exercises. And have a great day.